Hello friends, welcome to my channel Easy Mathematics. Today in this video lecture we discuss on the set theory. Set, which is the part of modern algebra or abstract algebra. Abstract, that means which we are supposed to visualize or think of. So what do you mean by a set? Set is a well-defined collection of objects or elements. So well-defined collection of objects. So first of all, collection, for example, we can say, suppose there is a home, our home, and on that home we stay the family members there. So the home we can say the set, and the family members we can say the elements of the set. And well-defined means definitely there are some relation between the members of the family so that they stay together. So definitely there is a relation among them. So that is a well definition is exist over there. So that we can say it is a well defined collection of objects. So for mathematically we can say the set of natural numbers. So set of natural number is 1, 2, 3, 4, 5. So if we keep all those natural numbers in the set notation, then this is called the set of natural numbers. One more example is the whole number. So the whole number is 0, 1, 2, 3, etc. up to infinity. If we keep it within the second bracket, then it is the set notation, and these are the elements of this set. Set usually denoted by the capital letters, and the elements are usually denoted by the small letters. Some another example we can think of the set of integers. Set of integers means it is minus infinity to plus infinity, all whole numbers. So this is the set of integers. So regarding the definition we can say all are integers. Similarly, here suppose the R is the set of real numbers. So all real numbers should be there. In this way, set can be defined. Now there are different type of sets we have. So the first one is the universal set. Universal set is what? The set which contains all the elements under consideration is called universal set, and which is denoted by capital U or capital S. For example, we can say the set of all real number is the universal set, because whatever be the real numbers are there, all are included over there. Another example for we can think that our college, if there are all students we kept on a set, then this is the universal set. From there we can consider the all boys or all girls. These are the subsets. So the universal set means for a particular type of thing or for a particular definition, if all the elements which match to this definition are included on a set, then it is called the universal set. Next one is the void set or the null set or empty set. So for a set which contains no element is called an empty set or the void set, and it is denoted by the letter phi, or it is by the just second bracket without any element. This is called the null set. Next it is the finite set. Finite set means what? A set is called finite if it contains finite number of elements. Very obvious. And infinite set is what? Which contains the infinite number of elements is called the infinite set. For example, the set of real number is an infinite set, whereas if we think of that a set A is there which contains the element 1, 2 and 3, then this is called the finite set. Next it is the singleton set. So the singleton set is what? A set which contains exactly one element is called the singleton set. For example, A is equals to 9. Only one element is there. That's why this is called the singleton set. Next it is the cardinality of the set. So what do you mean by the cardinality of the set? So cardinality is another set. So A union B means the entire this shaded region. So this is the Venn diagram for A union B. Similarly, A intersection B. A intersection B means the common portion of A and B. So this is the A intersection B. Now it is the A union B, its complement. A union B means all the white portion. Its complement means the shaded portion. So this part is the A union B, its complement. Next it is A intersection B, its complement. So A intersection B means this white portion. Its complement means except this portion, the remaining entire part, the shaded portion, is the A intersection B, its complement. Now if it is only B complement, two sets are given and B complement if you want, then this is the B. Its complement means except this white portion, the remaining portion. Next it is the A minus B. A minus B means A and the portion of B which is common in A, we just subtract these two. So this one is the A minus B. Similarly, A minus B complement means the entire portion except this white portion. Now A is the subset of B. Suppose B is the set and A is the set. A is the subset means A contains entirely in B. So that if this is our B, then we can say A is the subset of B. Its complement means except A, the remaining portion. So in this way, we can show the Venn diagram of different set notations theorem. Thank you. The number of elements in a set A is called the cardinality of the set, and it is denoted by the sign mod A or n of A. For example, if a set contains, suppose, 5 elements, likewise A is a set which contains 1, 2, 3, 4 and 5. So that we can say the cardinality of this set is 5 and it is written by this way. Next there are the next it is the subset. So what do you mean by the subset? If every element in a set A is also a member of set B, then A is called a subset of B and is denoted by A is the subset of B. That means if B is a set which contains 1, 2 and 3, then A set, if we consider it as 1, 2, then it is the subset of B. Otherwise, if we consider it is 1 only, then also it is the subset of B. If we consider the null set 5, then also it is the subset of B. So that if the elements of A are also the elements of B, then we can say A is the subset of B. There are two types of subset. One is called the proper subset, another one is called the improper subset. So the proper subset is what? Proper subset means if A is the subset of B and A is not equals to B, then it is called the proper subset. That means if we consider the set A as 1, if we consider the set A as 1, 2, 3, then the elements of A are also the elements of B. So we can say A is the subset of B. But now A and B both are the same set. That's why this type of subsets are not called the proper subset. Rather, these are called the improper subset. Proper subset means the elements of A has to be at least one less than the set B. Next, the equality of two sets. Two sets A and B are said to be equal if and only if A is the subset of B and B is also the subset of A. That means both are the same set. Next it is the power set, which is the most important one. So power set means what? Let A be a set. Then the set of all subsets of A is called the power set of A and it is denoted by PA. For example, let A is the set 1, 2. Then its power sets are, power set is denoted by P of A. Then these are, one is the 5, another one is the 1, next it is 2 only, and one more is the 1 comma 2. If we write all these 4 elements, four subsets as the elements of PA, then this is called the power set of the set A. We can say that in a power set there are total 2 to the power n number of elements. So look, in this set there are 2 elements and its power set have 4 elements. One is this one null set, these are the 2 singleton set, and this is the set itself. So it is 2 to the power 2 as there are only 2 elements. So 4. Total 4 elements are there in the power set of A. If a set contains 3 elements, then its power set contains 2 to the power 3, means total 8 number of elements, and these are first, second, third, fourth, fifth, sixth, seventh and eighth. These are the all elements of the power set. Next, it is the few operations on set. First operation is the union. So union is what? Union or these operations are taken over the 2 sets. So let A and B are the 2 sets. Then their union means we can denote it by A union B. So A union B means all those elements are there in A union B where they belongs in A or B. For example, let A be the set which contains 1 to 7 all elements. B is another set which contains 2, 5, 7 and 9. Now if you want to take the union of A and B, then we should write all the elements which contains in A as well as in B in the set. So here the union set contains 1, 2, 3, 4, 5, 6, 7 and 9. So 1, 2, 3, 4, 5, 6, 7 and 9. So this is the union. That means which element contains in A and B, all are contained in the union of AB. Now it is the intersection of the 2 sets. Intersection is denoted by A intersection B. And intersection means what? Intersection means there are 2 sets A and B. A contains some elements, B also contains some elements. Their intersection means which elements are common in A and B both. These are the part of A intersection B. For example, A is this set, B is the set. Then their intersection means which are the common elements. So for common element, 2 is the common element, 5 is the common element, 7 is the common element. So intersection contains 2, 5 and 7. Now it is the disjoint sets. 2 sets A and B are called disjoint or mutually exclusive if they contain no common element. That means A have some elements, B have some elements, but they don't have any common element. So that we can write A intersection B is equals to 5. That is the null set. Then A and B are said to be the disjoint set. Next, it is the complement of a set. So the complement of a set means, suppose A is the set which is the subset of S. S is the universal set. The complement of the set A is denoted by A bar or A complement, and this is the set which contains the elements of S which are not in A. For example, let S is the set which contains 1, 2, 3, 4, 5, 6 and 7. A is the set which contains 2, 5 and 7. Then the complement of A contains the elements which are not in A and the elements which are in S. So that here 2 is in the set A, 5 is in the set A and 7 is in the set A. So 2, 5 and 7. So excluding these 3 elements, the remaining are the part of A complement. So it is 1, 3, 4 and 6. So the complement of A is 1, 3, 4 and 6. Next, it is the differences of sets. The set difference of A and B is denoted by A minus B. And that means A set contains some elements. Suppose here A set contains some elements. B set also contains some elements. Now A minus B means the elements which are which are not in B but in A. So B contains 2, 5, 7, 9. Here the common elements are 2, 5, 7. So excluding 2, 5, 7, the remaining portion is in the A minus B. So it is 1, 3, 4 and 6. 1, 3, 4 and 6 is in the A minus B. If we want to take B minus A, then what happens? B minus A means the elements which are not contained in B. So here 1, 2, 3, 4, 5, 6, 7, these are the elements of A. B contains 2, 5, 7 and 9. So 2, 5, 7, these are the common elements among both. But the 9 is the element which is not in A but in B. So that B minus A is only the element 9. Next it is the symmetric difference. So the symmetric difference is another difference of the set A and the set B, and it is denoted by A symmetric difference B. So how we identify this symmetric difference, or the definition for symmetric difference? A symmetric difference B means A minus B union B minus A. So if A is this set, B is this set, then A minus B we know it is 1, 3, 4, 6 and B minus A it is 9. So that asymmetric difference B means the union of these two. So it contains 1, 3, 4, 6 and 9. Next there are some properties of set. So the first property is the commutative law. Commutative means A union B means we can write B union A. For example, let A is equals to 1, 2 and 3 and B is equals to A and B. So that A union B is equals to 1, 2, 3, A and B. And if we write B union A, then also it is 1, 2, 3, A and B. So this is the commutative law, always holds for the union of two sets. Similarly, for the intersection also the commutative law holds. That means A intersection B is equals to B intersection A. Next it is the idempotent law. Idempotent law means if we take the union of a set with itself, that means A union A, then the set A only we will find out. It is again very obvious. If A is the set 1, 2 and 3, and if we want to take A union A, then very obvious these elements are only 1, 2, 3, which is the set A. If we take the intersection of these two sets, that means A intersection A, then all the elements are common over there. So in intersection only the common part is there. So it is 1, 2 and 3. Next it is the associative law. Associative law means A union B union C, that we can write as A union within bracket B union C. And same for the intersection also we can write. It is the involution law. That is A complement, its complement is the set itself. If we take the complement of the set A and then again we take its complement, then we will get back the same set. Next it is the identity law. Identity law means what? A union phi is A, where phi is the null set, and it is very obvious. If A is the set 1, 2 and 3 and phi means it is the null set, then if we take the union of these two, then very obvious we will get the set A. And if we take the intersection of A and the universal set, then we will get the set A. If A is this set and if U is the set, suppose 1, 2, 3, 4 and 5, then A intersection U is 1, 2 and 3, that is the set A. Next it is domination law. Domination law is what? A intersection phi is phi and A union the universal set is the universal set. It is also very obvious. Next, the one more important law, that is called the distributive law. Distributive law means A intersection B union C means we can write A intersection B union A intersection C. Similarly, instead of the union and intersection, if they exchange their places, then also we can write accordingly. So this is our distributive law. De Morgan's law. De Morgan's law means A union B, its complement is equals to A complement intersection B complement. For example, let A is this set, B is this set, and S is the universal set, which is 1, 2, 3, 4 and 5. So A taken from this set, B also taken from this set. Now A union B is this one, and A union B, its complement is the set 5 only. Now A complement means what? A complement means it is A complement is 4 and 5 and B complement is 1, 2 and 5. So if you take the A complement intersection B complement, then it is the common element is only 5 in between them, so it is 5. So A union B, its complement is equals to A complement intersection B complement. Similarly, we can prove that A intersection B, its complement is equals to A complement union B complement. Next, it is the complement law. Complement law is what? A union A complement is the universal set. If A is this set, A complement is this one. If we take the union of A and A complement, then definitely we will get the set A. Similarly, A intersection A complement is the null set. If A is this set and A complement is this set, and if we take the intersection of these two, then definitely there are no common element between these two, so that ultimately we will get the 5, the null set. Next one, more important thing in the set theory is the Venn diagram. So Venn diagram, I am just showing you the Venn diagram for the different sets. So here A complement, how we denote it by the Venn diagram. So let this one is the entire set or the universal set, we can say, and A is the subset of this universal set. Then A complement means obviously the elements contains in the outer region of this A. That's why we can draw by Venn diagram A complement as this picture. Next, A union B means there are two sets. Let U is the